Find a possible solution for f of x given that f of x equals integral of e to the arctangent of x all over 1 plus x squared. Wow, okay. So my eye is immediately drawn to this arctangent of x. I'm not even sure how we'd go about finding the integral of an arctangent. But we're also drawn to right here where we have a two squares. Now you don't normally think of one as a square. It is. One is a lot of things in life, including the loneliest number. But we don't normally think of one as a square because it seems kind of obvious. That 1 times itself is like, well, okay, it is, I guess, a square. But it's usually thought of more as a solitary number. So if that's a square, then we can do a trig substitution where we would say that x equals tangent of u. And I'm just ignoring this part up here. I'm like, I don't know. Don't know. No idea. I'm going to kind of just work with what I have here, and then hopefully it'll solve itself, maybe? When you come across a math problem and you have no idea what to do, find something in there that you can do and just start working with that. I guess it's kind of an idea for life in general. When you come across a problem and you're just completely clueless, you're like, I have no idea how I'm going to solve this. Pick a part that you can solve, work towards that, and then after you've solved that problem, go on to the next part. So that's what we're basically going to do here. It's like, ignore that, try and solve this, see what happens. So we have x equals tangent of u, dx equals secant squared of u, because the derivative of tangent of u is secant squared. You can find that out on your own using tangent equals sine over cosine, which is sine cosine to the negative 1. There's probably some x's in here. And then you do the product rule and then the chain rule, and eventually you get secant squared of u. But it's one of those things where it comes up enough that it's worth memorizing. Let's see, we'll have a du here. And then I should probably solve for x squared. X squared equals tangent squared of u. And then solving for u, that will be arctangent of x squared. And I'm just going to write this down. So e to the arctangent of, nope. Get rid of the x squared there because u equals arctangent of x, not x squared. So e equals arctangent of x would be e to the u. Okay, I'll put that in the back of my mind, okay? Moving on. Substituting things in. Good. Oh, no, it's the same colors up there. Adds ambiguity. Dark purple it is. Okay. Ooh, that is kind of nice. Surprisingly satisfying, though still similar to dark blue. So we have e to the u, which is interesting. But then we also have 1 plus, and then x squared is tangent squared of u. Then we need to do the secant squared of u du. And then for this part, we know that sine squared plus cosine squared equals 1. Divide everything by cosine squared. And we get tangent squared plus 1 equals secant squared, which is convenient because we have this right here. So we have integral e to the u secant squared of u du all over secant squared of u. I don't like that green. There we go. Cancel, cancel, and we're left with integral e to the u du, which we do know how to solve. Okay, so that arctangent of x that we're so worried about, it actually just kind of took care of itself, which was nice, because I was kind of worried. When we got down here, we were able to plug in, solve for when we solve for u, we had it equal arctangent of x. Okay, so coming back down here, we know the integral of e to the u is just e to the u, which will then equal e to the arctangent of x plus c. Move this over here, straighten it out slightly. See if this is a possible answer. Yep, e to the arctangent. Yes! Oh, I feel so accomplished, though I know that most of that was probably just luck. Okay, find a possible solution for f(x) given. Okay, so to backtrack real quick, we saw on this arctangent of x, kind of clueless, a little bit of panic. That's okay. We rallied the troops. We then look at fixing what we can solve, which is 1 plus x squared, because we know that's x equals tangent of u. We plugged that in. We did our trigonometric substitutions. And then about halfway through, we realized what we could call this arctangent of x up here. That's just u, which gives us e to the u. Solving that, we then get a final answer of e to the arctangent of x as the solution, which worked out pretty well. Sounds good? That's how we approach this problem. I will see you guys in the next one. Go team.